Good morning, all. I got a new meter, the Fluke 87 Mark V. Now, this replaces the meter that died on me. I had a Fluke 87 Mark III, and I really like this meter, and it replaces the one that died on me. I miss that old meter, but we do what we do. Now here is a resistor that is above the range that my meter can measure. This is a 100 mega ohm resistor. 100 mega ohm. That is up there. So how can we measure this resistor if your meter cannot measure a value that high? Let's set our meter to ohms. Can I turn the light on? Can you all see that? There we go. Now press the range button until you're in the nano-Siemens mode. The Siemens is a measurement of conductance. And from that nano-Siemens value, we're going to determine what this resistance is. Now the formula, according to the manual that came with my meter, here is the formula. 1 over 1 nanosiemens is equal to 1,000 mega ohm. So let's measure the value of conductance. And it says we have 10.05 nanosiemens. We're going to plug that into our calculator and see what value we get. 10.05 nanosiemens. Let's write that down. The formula is 1 over 1 nanosiemens equals 1,000 mega ohms. Let's see if I can get my calculator up here and type at the same time. We have 1, 0, 0, 0 times 10 to the 6th divided by 10.05. Enter. And that gives us a value of 100 mega ohms. 100 times 10 to the 6th ohms. Isn't that amazing? So the value of our resistor is 100 mega ohms. Now I'm going to put 3 of these in parallel, and we'll be able to measure the ohmic value and calculate the ohmic value from the conductance value and see if they match. Let's try that. Let me get back into ohms, not mu, ohms. And here's 3 more resistors right here. Let me join those together with some jumper wire. 1. That's that one side, paralleled. Let's do the other side. Now, I have 3 100 mega ohm resistors in parallel. Let's see what our resistance value is. We have 33.18 mega ohms. Let's write that down. Let's go to nano-Siemens mode. and we'll see what value we get. We have a value of 30.14 nanosiemens. Let's write that down. Bring the calculator back into play. Try to hold still. 100 times 10 to the 6th divided by 30.14 nanosiemens. This is 100 mega ohms divided by 30.14 nanosiemens. Let's see what we get. We get 33 mega ohms. 33 mega ohms. And that matches our experiment passed. Okay. All right. That is nice. So, if you ever need to measure resistance that's greater than the ohmic range of your meter, and your meter has the nanosiemens function, you can do it. Okay. How y'all like that new meter? That's a nice one, isn't it? Shoo-wee. That took a good chunk of change out of my paycheck, though. Go and look up the suggested retail price on these things. Man. It's going to be macaroni and cheese for a couple of weeks after buying that. All right. All right, folks. That was a lot of fun. Got to pull out the new meter and the calculator and learn something new, something fascinating. Nice. All right, I've got 6 seriesed 100 mega ohm resistors. I'm going to put my meter into ohmic mode so we can measure the resistance. Now here's one 100 mega ohm resistor, and my meter will not measure that one resistor. So there's no way it can measure those 6 series resistors. Let's go to nanosiemens mode, and I'm going to clip one lead onto the end here. This is the beginning of the series resistors. I set that one lead off to the side right there, and we're going to measure through the first resistor. And we have 10.07 nanosiemens. Let me write that down. 10.07 nanosiemens. Now we'll measure 2 resistors in series. I have 5.02 nanosiemens. Let's write that down. Now we're going to measure through 3 series 100 mega ohm resistors. I've got 3.36 nanoseconds. Let's write that down. Now through 4, 2.53 nanosiemens. 2, 3, 4, 5. 2.02 nanosiemens. 2, And the last one. 1, 2, 3, 4, 5, 6. 1.75 nanosiemens. All right, let's move this all out of the way and we'll do a little bit of calculating. Aren't these experiments fun? I like doing stuff like this. That's amazing that this meter can measure such large resistances. Uh-oh, don't drop them. Our first measurement in the nanosiemens mode was 10.07 nanosiemens. So let's put 1,000 mega ohms divided by 10.07 nanosiemens. That gives us 99.30 mega ohms. The next value was 5.02 nanosiemens. That gives us a value of 199.20 mega ohms. That was 2 resistors in series. Our next nanosiemens value was 3.36. $297.62 mega ohms. We had 3 100 mega ohm resistors in series. Here's our fourth. Nanosiemens of 2.53. 395.26 mega ohms. Our fifth measurement was 2.02 nanosiemens. That gives us 5 series resistors measurement of 495.05 mega ohms. Now our last. This is 6 resistors in series. We had a nanosiemens measurement of 1.75. That gives us a total resistance, 6 of those 100 mega ohm resistors, a total resistance of 571.43 mega ohms. That is amazing. That is amazing. Now we could not measure those values without that nanosiemens mode. Isn't that amazing? Well, there you go, folks. If you have the nanosiemens mode on your meter, you can measure very large resistances. All right. Thank you very much for stopping by. I always enjoy it when you come over to see what we're experimenting with next. Have a good day. We'll see you next time.